Welcome learners, this is part 2 of module 2 unit 2 mineralogy, physical properties of minerals. In the previous video we have seen physical properties: crystal, form, color, streak, luster, fracture and cleavage. In this video we will be seeing hardness, density and specific gravity. So what is hardness? Hardness refers to the relative resistance of a mineral to scratching, distinctive property of minerals, governed by crystal structure and by the strength of bonds between atoms. Stronger the bonding, the harder the mineral. Relative hardness can be assigned by determining the ease or difficulty with which one mineral will scratch another. Upon all the minerals, talc is the softest mineral known and diamond is the hardest mineral. So hardness is the relative resistance the mineral offers to the scratch. One of the popular scales in which the hardness of a mineral is measured is Mohs relative scale. In Mohs relative scale, the hardness is subdivided into 10 steps, each marked by a common mineral. Steps do not represent equal intervals of hardness, but more importantly, any mineral on the scale will scratch all minerals below it. Often test relative hardness with the following: pocket knife, glass. The hardness scale is given 5 to 6, whereas the copper penny is 3 to 4, whereas in fingernail it is 2 to 3. Basically, how you identify the hardness of mineral is it is given in 10 steps from 1 to 10. Here what is given is the difference between 1 and 2, the hardness level between 1 and 2 and 2 and 3 are not the same. It is just a qualitative representation. It is not a quantitative representation. If I give you a mineral, normally the one you can easily scratch that mineral with your fingernail. If you scratch the mineral with the fingernail and there is impression created on it, its hardness, its relative hardness is given 2 to 3. But if you cannot make a mark while scratching the fingernail on the mineral, you can try scratching the mineral with copper penny, means a coin. If the impression is created, then the relative hardness of the mineral is given 3 to 4. Even while scratching with copper penny, the impression cannot be created. You can try pocket knife or glass. You can use glass or pocket knife to scratch the mineral to create an impression. If the impression is created, its hardness is given as 5 to 6. If the impression is not created, it is above 6. So these are the most relative scale of hardness. 1 being the softest, its resistance to scratching is least. Whereas the 10 is diamond, it is hardest. You cannot create any impression on diamond using normal tool. So in Mohs hardness scale, what we basically do is we are determining the hardness of minerals by comparing them to substance of known hardness. For example, if you scratch a mineral with fingernail and it creates impression, the hardness of that mineral will be less than that of gypsum and talc. If the impression is not created, the hardness of that material will be more than that of talc and gypsum. So the fingernail, the hardness comes between gypsum and calcite. Similarly, for copper penny or coin, the hardness comes between calcite and fluorite, 3 to 4. Similarly, pocket knife or glass, you can determine the hardness of a given mineral whether it is below 6 or above 6 in Mohs relative scale. So in brief, hardness, it is the resistance of minerals to scratching. It depends upon how the atoms are packed. One of the most popular scales of measuring hardness qualitative is Mohs relative scale. In Mohs relative scale, the minerals are classified into 10 types. Here we are determining the hardness of the minerals by comparing them with the hardness of the minerals we know. Each level is assigned with a particular type of mineral. Normally, the given mineral will be scratched either with fingernail, copper penny, or pocket knife or glass to determine the hardness, with the talc being the softest and diamond being the hardest. And also one more important point is, by using diamond you can cut all the minerals. You can make an impression by scratching all the minerals below it. For example, by using quartz you can make impression in feldspar, apatite, fluorite, calcite, gypsum and talc, but you cannot make impression by using quartz in topaz, corundum and diamond. Similarly, by using talc you cannot create any impression by scratching on any minerals, whereas with the diamond you can scratch any mineral to make an impression. So the next physical property is density. It is basically how heavy it feels. Density is mass per unit volume. Here the units are gram per cubic centimeter. The units can be anything like kg per meter cube also. Gold has of all the minerals, gold has a high density, 19.3 gram per centimeter cube. This is because in gold the molecules are stacked very closely. It is called as gold panning, whereas the molecules are stacked to the bottom and sides of the pan. Ice has, of all the minerals, ice has a low density, 1 gram per centimeter cube, because its atoms are very loosely packed. Most of the many common minerals have densities 2.5 to 3 gram per centimeter cube. So to determine the density of the mineral, we have to know the mass of the mineral and volume of the mineral. So density is nothing but mass divided by volume, where it's given in short form as D equal to mass by volume. Finding mass of the mineral is simpler, because if you have a weighing machine, you put the mineral in the weighing machine, you can easily determine the weight of the mineral. But since the minerals are irregular in shape, it is very difficult to find the volume of the mineral. There are various methods to find the volume of the mineral. Those are not direct methods. For example, if there is a cube or if there is a cylinder, you can easily determine the volume of the cube and volume of cylinder. But normally the minerals don't occur as cube or cylinders, so it occurs in irregular shape. So one of the easiest method is using the cylinder, glass cylinder, to determine the volume of the mineral. First we will be pouring water in the glass cylinder, and we will be noting down the how much volume the water occupies initially. Then we have to drop the mineral into it. Once we drop the mineral into the water in the glass cylinder, the volume of water rises. Again we have to note down the final volume after we drop down the mineral. The difference in these two volumes is the volume of the mineral. This is the very easiest method, but this can be done for a very small objects. In this way you can find the volume. So once you know the mass and volume, you can easily find the density of the mineral. But if you don't have a measuring cylinder, it will be very difficult to calculate the volume. So for that we will be using a container having water, and we will be dropping the mineral inside it, and we will be collecting the displaced water. The weight of the displaced water can be easily measured. Once the weight of the displaced water is known, the volume of the displaced water can be determined using the density of water. The density of water in gram per centimeter cube is 1. So the weight of water displaced will be equal to the volume of water displaced, which will be equal to the volume of the mineral. So by this way also, if you don't have measuring jar, you can easily find the volume of the mineral. So once you know the volume of the mineral, if you calculate mass divided by volume, it will give the density of the mineral. So the next one is specific gravity. It is very similar to density. It also describes how heavy the mineral feels. Specific gravity is defined as the ratio of the weight of a substance to the weight of an equal volume of pure water, ratio of two weights. So in the previous slides we discussed how to calculate density. Once you calculate the density of the mineral and divided the density of mineral with the density of water, you will get specific gravity. Specific gravity does not have any units. Density of water, since density of water in gram per centimeter cube is 1, specific gravity of a mineral is therefore equal to its density if it is measured in gram per centimeter cube. Normally, except metallic minerals which are very heavy in nature, all other minerals are light. So these are the various physical properties with which a mineral can be identified. Out of all the physical properties we have seen, only cleavage and density, you can use it as a diagnostic physical property for identification of minerals. So the next one is degree of transparency. It is the ability of the mineral to transmit light. So based on this ability, the minerals are classified into transparent, translucent and opaque. Whereas transparent is, if you pass the light through the mineral, it will easily allow the light to go through it. Whereas in opaque mineral, the light will not pass through. Translucent is in between. It's neither transparent nor opaque. Also, there are some special properties of minerals. For example, magnetite, since it contains iron, it exhibits magnetic property. And some minerals like fluorite glows under ultraviolet light. And also halite, since it contains salt content, it tastes salty. And you can identify sulfur with its smell. And some minerals like calcite reacts to HCl acid. And also there are some special properties like double refractive. A thin clear piece of calcite placed over an image will cause a double image. So if you draw a dot or line in a paper, and if you rotate a paper, or if you see that paper through calcite mineral, there will be two images, two dots or two lines. This is one of the special properties of calcite. And also minerals containing radium and uranium will exhibit radioactive nature, and those minerals can be identified using Geiger counter. Thank you.